All right, welcome to the next chapter in geometry. We're going to go into chapter 7, which is going to deal primarily with quadrilaterals. So four-sided objects. We're going to talk about a lot of different properties and special types of quadrilaterals. But before we get into that, we're going to talk a little bit about polygons in general, so just any type of shape, and talk about some of the angle relationships within them. So first thing, kind of review. So these first couple slides are going to be review. We've talked about this before back in first semester, but that's been a while. So we want to just kind of make sure we go back over this, make sure everyone's on the same page here. So a polygon is a closed figure with sides. And what's important about the this definition is that when we talk about sides, we're talking about sides that only intersect at the endpoints. So as I look at my four shapes down below here, if we're looking at this definition, we have this green trapezoid here off to the side. And as we look at that, we notice that it's closed. There's no openings. We have sides that we can physically see all the way around. And those sides don't cross over one another. They just meet at the endpoints and then turn and move on to the next part of the shape. So this would be considered a polygon. Now, if we look at the second example, though, we do have sides. So we have these sides here, and we have these sides here. And we have a closed figure, so there's no openings anywhere within the figure. But we notice right here, my two sides cross over one another, which is something that can't happen. So this would not be considered a polygon. In the third example, we have sides. We have a closed figure. There are no openings anywhere. And we notice that all the sides only meet at the endpoints. So this third object would, yes, be a polygon. As we look at the last object, which is a circle, as we start going through our definition, the problem we run into here is there are no sides. A circle is just one continuous loop. And so we don't have sides. It's a closed figure. We don't have any crossovers along the pieces, but there's no sides to work with. And so circles are not considered polygons. Okay. Now, as far as naming, and I'm not going to spend too much time on this slide. If you guys want to, you can pause the video at this point and get this table copied down. But we went over this before. This is just a refresher to kind of get you guys back on track with what the names of the objects are. Now, these ones from 3 to 12 are going to be the most common. Those are the ones we're going to deal with most often. And so you need to know those names, specifically because in a problem they might say, what are the sum of the interior angles for a heptagon? And you have to understand that a heptagon has 7 sides. So you need to know those names for each of these different polygons. Now, we're going to be dealing with other polygons besides these, and so we need another way to name polygons, which we can see right here on this statement. So polygons with n sides can be called an n-gon. So literally just call it the number of sides it has and attach the word gon. So down here, a 9-sided polygon is a nonagon. That's the official term for it, but using this shortcut method, we could just call it a 9-gon, and it means the same thing. So when we get to a figure like 20 sides, or we get to a side or a figure with like 30 sides, so 30 sides would just be a 30-gon. Okay? So make sure you get those names written down, make sure you memorize those names, and then also know that you can name using this shortcut method. Now, as far as the polygons in this chapter or this section are concerned, we're going to be focusing on angle relationships. And so one of the first ones we deal with is the interior angle sum. If I were to add up all of the angles inside, so if I took this angle plus this angle plus this angle plus this angle, I want to know what all those angles are going to add up to. And what we note is that no matter what the polygon looks like, all polygons with the same number of sides add up to the same amount. Triangles, we already know from previous chapters and lessons, triangles always add up to 180. That was one of the properties that we did every single time. So a triangle, no matter what it looks like, those 3 angles inside have to add up to 180. Well, that property applies to all of the rest of the polygons as well. And so every quadrilateral has the same angle sum. Every pentagon has the same angle sum. And so as we look at this, we're going to kind of build this formula here. So for this first object, we have 4 sides. Okay, so we can count the 1, 2, 3, 4 sides. And with that then, what we're going to do is we're going to talk about joining diagonals. So we're going to create triangles out of this polygon because we know what triangles add up to. It's 180. So if I take this corner here and I just connect it to all three other corners. Notice how we create a triangle here and a triangle here. Well, we know that this triangle right here adds up to 180 on the inside. We know that this triangle here adds up to 180 on the inside. So if I take those two 180s and add them together, my three or four-sided objects will always add up to 360. So this is something where every quadrilateral is going to add up to 360, and that might be something you want to commit to memory because they're going to show up a lot. When we look at the pentagon, so if I started a corner and I connect it to all the other corners in the picture, we notice that this time we create 1, 2, 3 different triangles. Each triangle adds up to 180. So every single triangle that I created is going to add up to that 180. And so in this case, I have 5 sides. When I connected my corners, I got 3 triangles, and that means I have 3 180s, or a total of 540. And again, I would commit this to memory. Anytime you see a pentagon, it's going to add up to 540 degrees. And so we can continue this process, and if we go to our 6-sided object, so we have our hexagon, if I connect all the corners, we see that we connect or create 4 different triangles, and so now we have 4 total triangles, and so if we add all that up, it's going to come to a total of 720. So what's important to note here is that every time we found the sum of the interior angles, we used how many triangles were in play. So how many triangles could we make, and then multiply that by 180. So if you notice the pattern here, I had 4 sides, which created 2 triangles. I had 5 sides, and I created 3 triangles. I had 6 sides, and I created 4 triangles. So the number of triangles was always 2 less than the number of sides. So if I had a 20-sided object, I'm going to be able to create 18 triangles. Each of those 18 triangles has to add up to 180, so I would take the 18 times 180 to get the total sum. And so that's the formula we need to know right now. So this is a formula you need to copy down in your notes. It's one that you're going to need to memorize. When I want the sum of the interior angles, I'm going to take 180 times the number of triangles, so how many sides I have minus 2, and it's always going to stay the same. So the number of sides minus 2, multiply that by 180. Now exterior angles are another thing we want to kind of take a look at. So exterior angles are when we extend sides of polygons. So notice in this rectangle on the right, if I extend this top side to the right, and then if I continue that process all the way around, so now I extend this side down, I extend this side to the left, and I extend this side up, what I notice is I get 4 angles on the outside here. So those are my exterior angles. And what's interesting about exterior angles, no matter what the shape is, so if I come over to my triangle here and I do the same thing, so if I extend that side and I continue around and I extend this side and I continue around and extend this side, so I get these 3 exterior angles right here. What's interesting is with any shape, so any polygon that we come up with, if we look at all of the exterior angles, they are always going to add up to 360 degrees. So no matter what they are, no matter what type of shape it is, the exterior angles will always add to 180 or 360. So triangles, exterior adds to 360. Quadrilaterals, exterior angles add up to 360. 20-gons add up to 360. So on the outside, all the angles are always going to add up to 360, and that's another relationship that's going to be pretty important. Now, regular polygons, this is a new definition, so you're going to want to make sure you get this written down. For regular polygons, it's a convex polygon, so remember convex just means it doesn't cave in towards the middle, in which all sides and all angles are congruent. So we see a picture of what that looks like down below here. We have this hexagon. All 6 sides are marked congruent. All 6 angles are marked congruent. And that's going to be true for any regular polygon. So for a regular pentagon, if they made a regular pentagon, they're going to say all 5 sides are identical, all 5 angles are identical, and that's what we're talking about every time with that. So with this regular polygon idea, as soon as we know it's a regular polygon, there's 2 things that we can find. We can find the measure of 1 interior angle, and we can also find the measure of 1 exterior angle. And we know that because if I look at this hexagon, we just learned how to calculate the sum, and so the sum of the angles inside this hexagon would be 180. There's 6 sides minus 2, so 180 times 4, which is 720. Now the thing about this though is, with this regular polygon, every single angle has to be exactly the same size. So notice, for this one interior angle over here, I have the 180 times the n minus 2. That's the sum of my interiors. So for my hexagon, it was 720. But then I need to divide that 720 evenly into the 6 different angles that we have. So that's where that n, the number of sides, is coming in. So I'm going to take the 720 for my sum and divide it by the number of angles, or number of sides. And so for a hexagon, one interior angle would be 120 degrees. We can do the same thing for exterior angles. Now the good thing about exterior angles is it doesn't matter what shape it is. No matter what shape we have, our exterior angles always add up to 360. So then if I'm looking at my exterior angles, so if I extend my sides out like here, if I look at those exterior angles, they all add up to 360 total. Well, so then all I have to do is divide by how many angles there are. And so in this case, I would take 360 divided by 6. And so in this case, one exterior angle would equal 60 degrees. So anytime we have that regular polygon, and that's going to be a key thing to look for, we can utilize either one of these formulas in terms of finding an interior or an exterior angle. Now, while we're here, one thing I want to note is this exterior angle formula is also going to be important for another main idea. If we rearrange this equation a little bit, we can calculate the number of sides an object has. So we can calculate n by taking 360 divided by an exterior angle. So if I know the measure of one exterior angle, I can take 360 divided by that, and I can get n, and that's just taking this equation and rearranging it. So definitely make sure you write down and memorize these 3 formulas, because we're going to be using them quite a bit throughout the process. So if we look at some examples here, just to kind of get us a little practice. It says for the first one, what is the sum of the measures of the interior angles of a 13gon? So looking for key phrases or terms, the sum of the interior angles. So the sum of the interior angles, when we wanted to calculate that, was 180 times n minus 2. So I want the number of sides minus 2 and then times 180. So for a 13gon, I have 13 sides. So I take 180 times 13 minus 2 is 11. And so then if I plug that in my calculator, we get a total of 1980 degrees. So most of the problems that you guys are going to come across in this section is literally just going to be, here's a description of the figure, find this particular value. And so it's just a matter of finding the right formula, plugging in, and solving. In the next equation, or problem, what is the measure of one interior angle of a regular heptagon? So heptagon, it's important to remember, was 7 sides. So my number of sides is going to be 7. We want one interior angle. And so that's where we go back to those formulas that we just had there. So one interior angle was 180 times n minus 2 divided by n. So we just have that formula right there. All we got to do is plug the values in. So if I'm looking at this one, I take 180. There were 7 sides, minus 2 means 5. And then divided by the number of sides, which is 7. And so then again, I would just plug this into my calculator, and we end up with a value of 128.6 degrees. And decimals are okay with these problems. Okay, some of the figures that we're going to deal with, we're going to have decimal angles, and that's okay. So just make sure that you plug things in to the formula, plug in your calculator, and then report what it gives you. In this third example, what's the measure of one exterior angle of a regular polygon? So again, we kind of focus. Regular polygon, we want one exterior angle, and this is decagon. A decagon has 10 sides. So one exterior angle from our formulas from before is 360 divided by n. And we said n in this case was 10, so I'm going to take 360 divided by 10. That means each exterior angle of my decagon would be 36 degrees. Okay, so again, it's just a matter of what formula am I using, plug in what I know, solve for what I don't. How many sides does a polygon have if one interior angle is 135? Now, one thing we didn't talk about on the previous slides that I want to take note of here, interior and exterior angles have a very specific relationship that we kind of glossed over in the examples from before. And so I want to write that down right here. So one interior angle plus one exterior angle will always equal 180 degrees. The interior and exterior angle, because we're just extending the outside for exterior, are always supplementary. They're a linear pair. So when I'm looking at this, I want how many sides the object has. Well, the only formula we had for the number of sides was taking n equal to 360 divided by an exterior angle. Well, in this case, they didn't give me an exterior, they gave me an interior. So the first thing I would need to do is figure out, okay, well, for an exterior angle, I'm going to take 180 minus 135. The interior and exterior always have to add up to 180. So if I take 180 minus 135, my exterior angle becomes 45. And so now I can go into my formula, take 360 divided by 45, and then if I plug that in my calculator, I get 8 sides. So my polygon would have 8 sides, it makes an octagon. On the second example, this one's a little bit easier because it says how many sides, so again we're looking for number of sides, does it have if one exterior angle. So this time they actually gave us the exterior right off the bat. So then all I have to do is say, okay, well, n equals 360 divided by my exterior angle, 24, and then again, if I plug that in my calculator, I end up with 15 sides, so we get a 15gon. Now the one that's a little bit trickier is this third one, and if we look at this third example here, it has how many sides does the polygon have if the sum. So we're looking for how many sides, but now we have the sum of the interior angles. So remember, the sum of the interiors was 180 times n minus 2. So this time, I know how much the sum is, so I know I have a 6,120 degrees. On the right side, if I'm going to solve for n, I'm going to go ahead and distribute, so 180n minus 360. And then from here, it's just a matter of solving the equation. So I'm going to take the 6,120 plus 360, and so we get 6,480 is equal to 180n. And then if I divide both sides by 180, we get n is equal to 36. So when you get the sum of the interior angle problem, we write out the equation, plug in the sum, and then distribute the 180 and then solve for n. It's just a matter of algebra there. So that's another one you want to kind of make sure you understand. Now the last couple examples here, we're dealing with, they give us a polygon with some measurements inside. We have to find whatever's missing. So in this case, they want us to find the value of x. Now the first thing we notice is this is a quadrilateral. So one of the things that we have to know with this type of problem, what do the angles add up to? So for a quadrilateral, if we have it memorized already, which I'm hoping we do at some point, I know that the sum of the interiors for a quadrilateral is 360. If I forget that or don't memorize that, I can still find it by taking 180 times 4 minus 2. So 180 times 2 gives me 360. Well, so what that means is if I add up all 4 angles, they have to equal 360 degrees. So if I take my x plus my 2x plus my 2x, all 4 of those angles have to add up to 360. And so if I go ahead and combine like terms, I've got 2, 4, 5, 6 x's is equal to 360. And then if I divide by 6, x would be 60 degrees. So with this type of problem where they give you the shape, you want to know how much it adds up to in the inside, and then add the angles on the inside to equal that total. So if we look at a second example here, if we look, we have 5 total sides. Now for 5 sides, if you have it memorized, you should know is 540 degrees. If you don't memorize that, you can still do this formula. So 180 times 5 sides minus 2 gives me 3. And so the sum in this case would be 180 times 3, or 540 degrees. So that means if I add up all 5 angles, so if I take 2y plus 2y plus, I've got my 2y minus 5, plus my 3y minus 25 plus my 120, I get 540. So this one's a little bit longer, a little more involved, but I'm just adding all 5 angles together. So now if I combine like terms, I've got all my y's here. So 2, 4, 6, 7, 8, 9 y's. And then I combine the other terms. I've got 120 minus 25 minus 5. So 120 minus 30 is going to give me 90. And that's equal to 540. And so then if I subtract 90 from both sides, 9y would equal 450. And so y would equal 50 degrees. And then for that, we just wanted y. If they asked us to find the measures of the angles, we'd go ahead and plug those back in, and we'd get our value from there. So with that, you have all the notes you would need to complete the assignment, which is a worksheet. So you can get that worksheet in class or off of Google Classroom. As you're working through it, again, it's just a matter of knowing the formulas, plugging in, and solving for what's missing. As you're working, if you have questions, make sure you ask, whether it's in class or email, or come in outside of class and get some help one-on-one, or you can also utilize the answer keys once those become available. So you should be good to go here, so good luck with that assignment.